So today we're going to do an example of a differential equation problem, okay, a diffie-q. And the reason I chose this problem is because when my students took this exam, they were completely lost. They came home and said, Mrs. Owen, this is crazy potato problem. I didn't know what to do at all. So we are going to kind of pick this apart a little bit. And just remember, differential equations, what are they? What the heck, right? Differential equation. So usually they give it to us in dy dx, right? Okay, like your homework tonight is dy dx. What does dy dx tell us? Always, 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 it's giving us the slope, right? The rate of change if you're looking at dt, right? So this is really good. So this gives us the slope. So if they say find all the points where the slope is horizontal, you would let dy dx equal 0, right? For horizontal. For vertical, you would let the denominator of dy dx equals 0. So I'm going to put denominator equals 0 for dy dx. Denominator equals 0 for vertical slopes. If they want a tangent line, this is giving us the slope, right? And they have to give us a point, okay? You can't write the tangent line without a point, so they have to provide that point for us, okay? The other thing, do we know if the function is increasing or decreasing based on dy dx? Yeah, you're darn tootin' we do, right? If the slope is positive equals a plus, we are increasing. If dy dx is a negative, we are decreasing, okay? Can we take the second derivative? Yeah, you're darn tootin' we can. So if we take the second derivative and it's positive, we are concave up. Yep. So I'll put that over here. It's positive, we're concave up. And if it is negative, we are concave down. All right, so a lot of things going on here with a differential equation. Now let's apply what we know to our free response question. Okay, time t equals 0. Our boiled potato is left on the stove to cool in the kitchen. It starts out at 91 degrees. At t equals 0, the internal temperature is greater than 27 degrees C for all time. So it never gets below 27 degrees. Okay. And then they're just telling us what the differential equation is, the temperature of the potato versus time. Okay, and then they tell us h of 0 is 91, which they told us up here. H of 0 is 91. So they're giving us what information with this? You're absolutely right. That is our point or our initial condition. And they have to give us that starting point condition. Our initial condition is h of 0 is 91. Okay, and then our dh dt is equal to negative 1/4 h minus 27. And that's basically all the givens. That's all they gave us. Okay, now they're going to ask us a question. Write an equation for the line tangent to the graph. Okay, equation for the line, what do we need? I know you yelled that out. You said point and a slope. Okay, they gave us the point, right? 0, 91. And instead of x and y, this is where we get all confused. Instead of x and y, we're using t and h. Very strange, right? Okay, but we can still use y and x if you want. It doesn't matter. You can write it either way. Okay, and then the slope is what at t equals 0. So, okay, we've got to do dh dt at t equals 0. All right, let's find it. So negative 1/4. Don't put 0 in here, right? At t equals 0, h is 91. So we're going to put in 91. And 91 minus 27, let's see, 90 minus 30 is 60, so 64. Okay, so this is negative 64 fourths. 4 goes into 64 16 times, right? So this is equal to negative 16. And what would, oh, we don't need to worry about units because we're just writing an equation of a line. Okay, so then our equation is, now we can use h of t and t. I think I'm going to do that. I'm going to write it with y and x first, and then I'll convert it so you guys can see how that might be done. So y minus 91 is equal to negative 16 x minus 0. Now I think the AP scorers would give that full credit. I don't know, but I'm going to add my 91 over. So now I have negative 16x plus 91. And then I'm just going to convert it to h and t just to be on the safe side. So I'm going to say h is equal to negative 16t plus 91. And I was going to put in h of t, but I don't think I want to do that. I think I'll just make it h. And that's our, sorry about that mess there. My eraser isn't working great. There we go. Got it. Whoops. My light. Okay. Good, part A. Oh, for goodness sakes. Darn light. It's very wobbly. Okay. Let's do part B. Okay. Now we are going to use the second derivative to determine whether your answer in part A is an underestimate or an overestimate. Okay, so now we have to take the second derivative. So, oh, I think I'm going to distribute that. So let's do negative 1/4 h plus 27 over 4. Okay, now we can take the derivative. D squared h dt squared is equal to, now I take the derivative of this, negative 1/4, and when I take the derivative of h, this is the tricky part, I have to write dh over dt. Just like if we took the derivative of y, we would write dy dx. And then the derivative of a constant, which goes away. Okay, so now we're saying t is greater than 0. I have to think. Okay. Okay, so let's see. Oh, at t equals 3. Okay, so I need to solve dh dt for t equals 3. So I'm going to do that over here. dh dt is equal to, oh wait, I forgot. No wonder I'm confused. I forgot to do a part of this. Okay. Okay, remember to go back and read the question again before you move on. That's a good lesson to learn, isn't it? Okay, here we go. Write an equation for the line tangent at t equals 0. Okay, I did that. Now I have to plug in t. I need to do the second part. Okay, use this equation to approximate the internal temperature of the potato. Okay, so h of 3 is equal to negative 16 times 3 plus 91. So that would be negative 48 plus 91. So 90 minus 50 is 40. 1, 2, 3. So I would say a positive 43. Okay, so that is going to be degrees Celsius is h of 3. So that's our approximation. Okay, so at that approximation, dh dt is negative 1/4. Now I'm going to use this temperature. I'm going to plug it back in to this equation. So I've got 43 minus 27. And of course, it is less than 0, right? Because it's negative. This is positive. Positive times a negative is negative. So I'm just going to say less than 0. I'm not even going to bother calculating it. I just know that it's less than 0. So if dH dt is less than 0, then d squared h dt squared at 3 is greater than 0, because I'll have a negative times a negative is positive. Therefore, h of t is concave up. Oh, goodness gracious, you can't see anything that I'm doing. Sorry about that. Okay, therefore h of t is concave up. So if you can imagine our function here and our tangent line, so our concave up function, and our tangent line is always going to lie below the line, right? So concave up, so our estimate is, what wording do they use? Is an underestimate. Okay, so we finished those two. And go back and make sure you answered that at, oh, maybe I should say at t equals 3. But I think that's okay. All right, now let's do part C. Now part C you don't have to do on your homework tonight, but it'll be interesting. You may have to do